Hello guys, and welcome to my tutorial on how to draw with Grasshopper and KUKA PRC. This is basically, I'm going to show two ways of setting up a KUKA robot to be able to draw a series of curves or any sort of input you give it. I'd say this is more directed towards people with a little bit of understanding, like a beginner of Grasshopper to the more intermediate type user. Having said that, I'm not really going to go into much detail on things such as setting up the cell for a KUKA, collision detection or custom tools, even though I'll touch on them. I think there's enough information in those sort of areas to warrant their own video and a bit of tutorial to make sure people understand how to set that information up. Having said that, let's get started. We're in a brand new Rhino model. I've got everything already set up. I've got the location of the KUKA robot that I use, as well as the objects within the cell, such as the tables that don't move and the cell itself. So just for a bit of rough collision detection via sight without having to worry about that. But for this tutorial, we don't really have to worry about any of that. So just turn those layers off for now and load up Grasshopper. Of course, you can get Grasshopper from grasshopper3d.com, and I guess we'll get started. So say I've got some curves in Rhino already. We've got just the typical hello world, and we want to be able to get the robot to draw those lines in the real world with a pen. So the first way I'm going to show is the simple, basic, what I'd call is the basic way. It's not as accurate as how I'd normally like to do it, but we'll do both. So firstly, we'll pull in our curves, and we'll set multiple curves, and we'll do it in order so that we ensure the robot does it in the order that we wish. Just a matter of clicking each curve, hit enter, and we've got our curves into Grasshopper. Now we can turn off that layer because we've referenced it and we don't need to see that anymore. Now that we've got our curves, we need to turn them into a polyline, which is simply under curves, utility, and curve to polyline, which divides our curves into polylines. Now if we zoom in, we see that the polyline, we're getting a bit too few points along our polyline, which is our tolerance distance. So what we'll do is we'll set up a number slider to 1, maybe have, and we'll put that onto our tolerance distance. As we increase that, you see we can increase that. We'll be able to see this bit better, but if we have it on 0, then it all becomes a bit too faceted as we don't have enough points. So we'll just increase that to something like 0.18. Perfect. Can't see the distance, the difference between the two, the polyline and the curve, which is exactly what we want. Now we need to set up a series of control points so that we are basically telling the robot where to move on these lines, which is under curve analysis control points. We will take our polyline, put it into our curve, and that gives us a series of control points on those polylines that we've created. So if we can show what happens when we increase the tolerance. So basically that's saying the distance we're willing to move away from the original curve. Yeah, around there should be fine. We've got a nice, beautiful curve on our round areas. And on the straight, we don't need any points where it's just a straight line, which is perfect. So now that we have all the control points for our robot to run down, we have to attach a plane. So we'll go in, and because it's flat, it's on the XY, we'll create an XY plane. Our points, control points to the origin, so we get a plane on each. You see now we've got a plane giving the Cartesian directions for each point, which is exactly what we wanted, very straightforward. Now we're getting into the KUKA. We've set up thing. What's a bit, just before we get too far ahead, let's say we're going to be drawing this on our table, so we just move this up. So we've got a piece of paper on our table. Move it across as if we're actually drawing. And there. Beautiful. Perfect. So we'll be drawing on a very thick piece of card by the looks of it on the table in front of our KUKA robot. So we've got our planes. Next thing is to set up the movement of the robot. So under KUKA PRC, which you can access KUKA PRC from the Food for Rhino website. If you just type in KUKA, search, it's your first result, which is KUKA PRC, where you can get a free trial version, which is a very powerful tool. Another one is HAL robots, which you can also control most of KUKA as well as other robots through Grasshopper. But for this tutorial, we're sticking with just the KUKA PRC. So now that we've got our plane set up, we need to give the movement for the robot. What we can set up is we want a linear movement, which is under KUKA PRC call. Our planes into linear, which gives the commands out to the robot of where it's to move. But say this works really well, but say you've got a tool that you want to orientate to a point. You can do that also by orientating the planes to a point. So we put our series of planes in here. We'll create a point, geometry point, set a single point. Let's say we want to orientate it to the front of the robot. And we'll put that in there. And instead of going straight from the planes into our linear movement commands, we can put it in there, and we can, if we look in, can see all of our planes have shifted slightly. We'll hide all of this now. I think we don't need to see that. Just middle wheel click and turn off disable preview. We can get rid of our curves as well. And there's our plane, so we can see that we've orientated them towards, they've all got, so the ones that are further away sort of tilt, which you might not want to use if you're doing something like calligraphy. You'll have your angle set and you want your pen to be angled the entire time. So we've got our linear movement. And the next, I'll just put on our curve actually so we can see, preview our curve so we can see what we're doing. Might just get rid of our base as well, table. So what we don't want is the robot is going to come around this circle of the O in hello, and then the next command is to move to say this point. So it'll start here on the O, draw, and unless we tell it to take the pen off and move vertical in the Z direction, then come over and come down in the Z direction to start the W, it will just draw straight across, so we'll get a line across here. So what we need to add in is a tool offset with distance. So we've got the KUKA PRC tool axis offset. The commands we take from our linear movement, we put them in here, and then all we need is a number slider. So we're dealing in millimeters, so we'll say 0 to 20, and we know that our pen doesn't need that far, so we'll just say come up, say 10 millimeters off the board. So between each curve, the KUKA will move up 10 millimeters, move across and then come down 10 millimeters for the next curve to start drawing. Now that we've done all that, we can set up our KUKA core. So under KUKA PRC, we go to 01 core, and this is our robot. This is what converts all of these points into the KRL, the KUKA robotic language. We take our commands and put our commands into our commands. Then we need to insert a tool. So we'll grab our tool, virtual tool, custom tool. We'll just start with that. Now we'll put the tool into the tool. Perfect. Now I've got my drawing tool set up already. So if we zoom out, there's the mesh of my pen gripper holder I've made for our KUKA PRC. So if we want to show that on the end of the robot, well, first we'll put in the robot, sorry. We'll put in I work with a KR120 with R2500. So that's this robot, but you've got most of the KUKA robots available. So we'll grab that and set that as our robot. Now, that doesn't look quite right, because if you look, you can see that it's doing all the commands at once, as if there's 20 robots all in occupying the same space. That is because we haven't flattened our commands. So the step here will be to flatten, to make sure that our commands are being done in order instead of being done all at one time. So we'll flatten, and there's our robot at that point through the simulation. Now you'll see if we put a number slider 0.0, give it plenty of floating integers to 1, we can then control the simulation. So there's our start point, 0. We drag this through, that simulates our robot. Now you can see straight away something's not right. If we show the table, the KUKA is colliding with the table, and we know that the pen's going to be coming off. So now that we can see our robot, we'll just turn it off for the moment. Turn off its preview so that we can set. We'll put in a mesh, which is just from, if you don't know, it's under parameters and geometry. I'm going to set one mesh. If people are interested, I will potentially make a tutorial on setting up your own tools and how to accurately set them up both on the KUKA PRC as well as in Grasshopper. So we don't need to see that anymore. If we hide that, we can see our tool being referenced inside of Grasshopper. And we put our tool mesh into our geometry. We don't need to see that anymore. We can, when we preview the robot, we can see that our tool, our pen holder, is now on the end of it. And that doesn't look very right. The KUKA is colliding with our table that will be holding our cardboard or paper, and the tool is painting the wrong direction. To fix that, you have to set up your TRC and also your information. So this tool is, we'll set it to 0. It's 0 in the X direction, 0 in the Y direction. But the point where the pen will be hitting the paper or the canvas is 320 millimeters away from the base of the robot. Not the base, sorry, the end of the robot arm. And B, tool direction B, which is rotating along the Y axis, will be minus 90. Perfect. Confirm that, and we should see the tool rotate into the correct position. So now the robot knows what tool is on. It's 320 long and it's rotated down so that it's going down in the Z direction. So the tool now lines up with all of these planes. And that is the simple way, the basic, what I'd call the simple or basic way of drawing or setting up an engraving. You could have a tool bit on a spindle, and that's that done. So if we put in the KUKA play button, which is provided in KUKA PRC, we can simply set this. Just quickly set it back to the start. If we put in the simulator to the simulator in the core, play. And there's our KUKA KR120 doing our drawing. Now you can see that it's doing the offset in between each pass. Beautiful. So that's the simple way achieved. Now, while I was at university, the drawing became the activity that I would be asked to show, say, kids coming from high school or primary school would come in, and the school wanted to demonstrate our KUKA robot. So, you know, more advanced things like hot wire cutting or drilling and milling. There's no real quick way to demonstrate the robot or its capabilities, so I set up drawing. The kids would come in, see the robot, have a quick introduction, and then with 20 minutes I had them drawing on a tablet, uploading the source files and running the robot themselves as a real quick introduction. And of course, to show off the robot in a more visually pleasing manner than just having it drawing flat down on a table, it was always interesting to draw on a canvas or set the robot up in a different sort of position. So that's what we're going to do for the next step. This is great. Like, this is simple, it's there, but it's not parametric if you're moving your canvas around the room like I was, or people were setting up and moving around the robot in between my time on the robot. It meant I had to set everything else. So the next step is sort of taking advantage of more of the Grasshopper side. So what we're going to do, we've done our simple step, which is great. What we're going to do is we're going to do a bit of a more advanced way of setting up a drawing. So we'll just disable that for now. So everything disappears. We'll get rid of our table. So picture in your head, you've got 20 kids coming in. They all want to draw something on the tablet, export the curves, and you don't want to be sort of moving drawings around in Rhino every time, trying to get it as accurately lined up because you've got 20-30 kids to get through. So this time what we're going to do is we're going to set up something a bit smarter so that we don't have to mess around. We're going to pull in a geometry pipeline, so that's going to reference anything on the layer. What we're going to do is we'll make a new layer and we will call it drawing, which will be where we put the individuals coming in drawing. In the Grasshopper, we'll reference the layer drawing and we'll set it to curves. So now we've got a geometry pipeline. Anything that's on this layer is going to be referenced in this Grasshopper component. So now we will import a drawing. I've set one up earlier, just the hello world. Import preserve units. And there is our curves. Why hasn't that? Oh, it's because there's nothing on the layer. I've got to make sure it's on the layer. There we go. So we can turn off the visibility of that. And there's our hello world. Now I know the canvas that we're working with is 1 meter in X and 600 wide. So that has been imported based on 0, 0, 0 in the Rhino Cartesian space, which is exactly what we wanted. So that's just on ground level in the cell. But that's not where we want to draw. What we're going to do is we're going to set up a custom area for it to orientate the curves that we import and then to draw. And that way all we ever have to do is change the curves that are imported on our layer, go from there. So for this, we're going to construct 3 points. Construct point. We will put on, let's see, we will be going from to 1800. So we know we've got a relatively large canvas size. We'll duplicate that just by clicking, dragging, and then holding down Alt. Allows us to duplicate any component. Put them into our construct point. So what we're going to do is we're going to start with our origin point, which will be, so if we move this to 0, 0, 0, that's the point that this has been imported on, which is just the standard of importing an Adobe Illustrator curve. But so we don't need a point there. We need the points too. We need to think about where our canvas is going to be set up in the real world in the cell to start. So we'll say that we've set up our canvas. It is at 1600 in the X direction. In the Y direction, we are 200 millimeters, and in the Z, say we are 1200 off the ground. So there's the corner, the bottom left corner of our canvas. Beautiful. Now we've got the 3 points. You only need 3 points to create a rectangle. So now we'll keep our sort of bottom left corner in the middle. Then we'll move up in the Z direction. Go to 1800. So there's 1800. There's the top left corner, which if you look down here, it would be about here for our import area. And for our bottom right, we will bring this minus 800. So that means we've got a canvas that's 600 tall and a meter wide. So a lovely large piece of card. Now we need to construct the plane that we can reference from our imported data to our new canvas. So to construct a plane, it's simply in vectors, plane, construct a plane, and our origin point is going to be our 0 point. So on our canvas, we've got to imagine that that's 0, 0, 0. We're taking 0, 0, 0 of our imported data down here, and we're orientating it up here to then create the robot linear movement paths on the canvas. So we'll put our orientation, our origin point there. Okay, so now we've generated our plane. Zoom in here, we can see that the plane is on our standard XY Cartesian space. If we just zoom, it matches the world space of the Rhino file, which is why we've set up the 2 extra points from our bottom left corner. So now we need to set the X and Y directions so that they're correct, which means we'll go into vector, 2-point vector, our origin point, which is always this one, we will say is A, and then for Y, we've got our one that we've moved up, is B. So that creates our Y, and we'll add that to a group and just call it Y, and we'll make it the international color for Y, which is green. We'll click our 2-point vector, hold down Alt and move it down Of course, our origin stays the same, but we're shifting our B point to be in the X direction. We'll do the same with this. We'll put it in group, call the group X, and change the color to be red, which is, of course, the standard for X, which is our X direction for our plane. Now, if we zoom in, we can see on our plane that the Y direction is moving in the Y, what we want our canvas Y to be, and the X is moving along the X. But just to be able to even better demonstrate and visualize, especially if you're on a group project or something like that, you might want to be making sure that people understand what you've done. So under display vector, our anchor point will be our original point. We will hold down Alt and duplicate that. Then we will display our Y, and then we will display our X. And just to make that even more clear, should anybody wish, we can put on display a 3D text tag. Location will be our Y point. And the tag will be, we will set text to be Y. Commit. Size, set number size, say 20. No, we'll put in a slider, 1 to 1, 0 to 100. There. Text tag. Specification. We don't want it to be on that. So what we'll do is it's currently on the XY plane, which is what we've just been messing around with. So what we'll do is we'll put it on the YZ plane. It's just a matter of taking the point, the origin, and then the plane, and that turns it around. Just move that out of the way. We will put on a color swatch to keep the theme that we've got going so that people understand. We'll change that to a lovely bright green for Y. Then we'll hold down Alt. We'll change the location of our YZ to the X. We will right click on our text and say set text to be X. Of course, X is always red. And we will just justify that bottom right. And there's a very easy way to understand that we've set up our new plane, this plane, Y positive, X positive. So we can just set that aside because that's just for visualization so that we know what we're doing, and if anybody picks up our script, they know what we've done as well. So now that we've displayed our visualization, we know what we're doing. We need to get our imported curves to where our canvas is going to be within the robot cell. So our next step is to orientate. So to orientate a plane, we are going to transform, Euclidean, orientate. Our geometry that we're going to be moving, orientating, is our pipeline. So we'll say that we're going to orientate that. A is the source plane, which we know that this has been imported as 0, 0, 0 as the thing. So to reference that, all we need is a plane on the XY. So we'll put an XY plane in here. We'll say our origin point is there. You can see our plane's referenced here. And we're orientating it to B, which is the plane we've set up in the previous step. We'll take this plane, put it on B, and there. our curves have been perfectly orientated to where our canvas is going to be. Now say you're with your robot and your canvas is on a lean, or you're doing it on a surface. And if you're doing it on a surface that's not quite parallel, then of course everything updates. So you just get your actual point when you measure with your KUKA Robot, get your corners from the robot, and just put in where your canvas actually exists in the real world, and everything updates. Just in case people are coming into your cell and moving your stuff around, it's quick and easy, and you don't have to rewrite all your script. You just got to change 1 or 2 sliders and everything updates without having to worry about it. So now that we've got our information, our curves properly orientated, we need to set up the paths just like we did in the previous step. So we'll go through this nice and quickly. We've got our KUKA. We need to convert our curves to polyline, which is under curve and utilities. Our curves are the ones that we've referenced on our new canvas area. Distance from the last one, we know we want to use 0.18 or whatever suits depending on your curves that you've drawn. Beautiful. So now we've got our curves. Now we need to put on the control points, which is curve analysis control points. Got our points to reference. Now we need to, this is where the tricky part is. If we just use these points are just referencing the world X and Y. So here, they're the standard X and Y. So if I put on planes, if I use these points just as we did here with the XY, they're using the standard world XY. We want to use our plane here, so we need to, if we hold down, click and hold down Alt, move down our new constructed plane. Instead of the origin point being here, we'll use all of our new points. And there we've got our points set up in the correct orientation for our drawing. Now that we're at this point, we can just take our KUKA setup from the previous simple example, click, hold down Alt and drag it across, and put in our new series of commands, and middle mouse, enable, and hit play to test our simulation. And there is our KUKA going through the process of drawing on the canvas we've set up inside the cell. So there's the cell, the KUKA is inside. All we've done is import. Now I'll do this in real world to prove that it works. And just to demonstrate the benefits of this, say you've got another drawing, you can just select what's on the drawing layer, delete it. No, just delete the curves, please. Curves. We get an error because there's no information coming from that layer. File import. And we've got a scribble. So all I've done is ran a filter to scribble the text. Having the scribble, it automatically orientates, updates everything. If we go into our KUKA, click KUKA PRC settings, browse, desktop, okay, and Karl's drawing tutorial. Click apply, complete. On our desktop, we now have Karl's drawing tutorial file, and now it's just a matter of taking that over to the KUKA Robot and making sure everything works in the real world. Here we are with the KUKA remote control. Now it's just a matter of finding the file we've exported, copying and pasting it onto our KUKA robot, and running the script to make sure that everything worked well. Thanks a lot for watching, guys. Hopefully some of you found this tutorial pretty helpful when starting out with Grasshopper and KUKA PLC. I've made the Grasshopper file as well as the Rhino file available in the video's description. All that I ask is that you guys like and subscribe, and leave a comment if you'd like me to show anything else on the KUKA Robot or Grasshopper. I'm hoping to do a few more tutorials in the future.